So, Maria Kelleher is our speaker this evening. And I think I've known you since like the late 70s, Maria. She is an Irish-Canadian environmental engineer who specializes in waste management and energy research projects. She graduated with a civil engineering degree from the University College Cork in Cork, Ireland. She received a master's degree in environmental engineering from the University of Toronto and a diploma in environmental health from McMaster University, also in Canada. She has worked in recycling and as an environmental consultant for over 30 years. And her recent projects include how to recycle electronics and how to reuse and recycle consumer and electric vehicle batteries. Maria's areas of expertise also include solid waste management, printed papers, packaging, and other materials, and projects which combine waste management with greenhouse gas reduction. She is speaking with us tonight from her home in Toronto. Welcome, Maria.
Thank you, Phoebe. And I can share the screen. Where is my?
You can indeed.
Yeah, here we are. Share. Okay, so nice to meet you all from a distance. I'm going to talk tonight about the reuse and recycling of batteries from electric vehicles. So now, Bruce, how do I get on? How do I get on?
Want to go to slideshow and then from beginning.
From beginning? Okay, I can try that. Okay.
There you go.
All right. So I will talk about an introduction to electric vehicles, factors that impact on the growth in electric vehicles over the next number of years, and then get on to what do we do with electric vehicle batteries when they are done in the electric vehicle. And then at the end, we can have questions. So we've had electric vehicles for a long time. In the late 1890s into the early 1900s, they were very popular. They outsold gasoline cars about 10 to 1. And if you look at early 20th century pictures of New York City, it shows these lovely silent electric cars on the streets. But the early electric vehicles had a challenge with the battery design, and they were working on the battery design when Henry Ford came along. And sort of the same time, there were large discoveries of petroleum, which gave a cheap fuel for vehicles. And the fuel cars used to be really smelly and noisy, and the electric starter and muffler were invented, and it made it easier to start these vehicles, and they weren't as noisy and dirty. And so the mass production started in 1912 and with Henry Ford, and we know the rest of the story. For the next 108 years, that was the technology that most of us use. And so here's a picture from it should be 1913 actually, Thomas Edison with an electric car. So that's 107 years ago. And so they were forgotten about for about 60 years, but in the late 60s, early 70s, people got interested in them again because of air quality issues and concerns, and also the OPEC oil embargo. And then in the late 90s, California had a zero emission vehicle mandate, which prompted a few car makers to look at electric vehicles one more time. And then in 1996, GM produced about 1,000 units of its EV1. If you've seen the movie Who Killed the Electric Car, they only allowed people to lease these cars, but then they sort of killed the project at that time. So things began to change around the year 2000, and this actually does matter in terms of looking at the batteries that we're seeing today, in that Toyota produced the Prius in Japan in 1997, and it became available worldwide in the year 2000. So it really is the first mass-produced hybrid electric vehicle. And Toyota sold 50,000 Priuses the first year it was launched, and they were quite surprised. They didn't really know how popular this a product would be. So by 2012, they had sold 2 million worldwide, and as of April this year, they had sold 15 million worldwide. So that has been a big success for Toyota. And so they were quite surprised, but they've developed other hybrids, plug-in hybrids, and now electric vehicles as a result of that early start. So when you look at North America, in about 2006, Tesla decided to launch a battery-powered car with a 200-mile range. So in 2011, the Tesla, the Roadster was launched, and then the Model S in 2012. By 2018, they had actually produced 200,000 units. And looking at Nissan in 2010, they developed the first all-electric, the Leaf, for the US market for budget-conscious consumers. And so to date, the Leaf really has been the best-selling full-use electric car in history so far, with 450,000 units up to this year. Looking at other car makers, GM made a big push into the electric space starting in 2016 with the Chevy Bolt. It had a range of about 200 miles. And what's been a big driver in the market recently is that China, in the last year or two, has said, if you want to sell into the Chinese market, you have to have an electric option. And that has absolutely been a complete game changer for all of the auto manufacturers. So because the Chinese market is so huge, it's actually, for Volkswagen, is 40% of what they sell. So they just, you know, turned on a dime and said, okay, we're going electric. So we look at 5 major factors when you talk about how quickly will people adapt to electric vehicles. And it's a bit hokey, but it is easy to remember because it's CARMA, C-A-R-M-A. So it stands for the charging infrastructure. Are the cars affordable? Do they have range? How available are they? And then how aware are people that they exist? So I'll just go through these fairly quickly. And some of these slides are a bit old because they come from a big study I did actually for the American Petroleum Institute when they wanted to look at electric cars a year ago. So in 2017 in the US, we had 47,000 charging points for electric vehicles. And today we have 78,000. So the charging infrastructure is getting built out and will absolutely be there in more remote areas within the foreseeable future. So that's that problem resolved. When you look at electric vehicles, a third of the price is the battery, and the price of the batteries for electric vehicles have been coming down very dramatically from, these numbers might be a little bit out, but you can see 2018, a price of 176 per kilowatt hour versus 1100 8 years earlier. So the price of the battery is dropping, and that is really changing many things in the market, including energy storage and other stuff I'll get to in a minute. And so when we look at this chart here, it shows how the price of the battery has dropped over the last few years. And the projections are really that when the battery all-in price gets to about 100 kilowatt hours, dollars a kilowatt hour, the price of the battery will be sufficiently low because it's a third of the price of the car, that the price, the overall price of the car will come down to be actually less than a gas car. 2-3 years out was the projection a while ago. I don't know how COVID has altered that. So looking at affordability, a number of states have incentives that make the car a bit more affordable. We did have one here in Ontario, which is very generous, but the government changed and now it's a lot less generous with a different government. So when you look at affordability, we're not quite there yet in terms of an equivalent car still being a bit more expensive if it's electric versus internal combustion, but the gap is getting to be less and will be gone within 2 or 3 years. So the next issue is range anxiety, which is a big issue for most people. What if my battery runs out of power and I'm in the middle of nowhere? So the range of the batteries that go into electric vehicles has changed dramatically, certainly since 2011, which is on this chart, with the Teslas easily able to get, the expensive ones, able to get 300 plus miles on one charge. And so in terms of model availability, this is an old chart from Statistica, but by 2017, you can see there were over 50 models available. There's probably over 100 now, but there's lots of choice in the market. And so one of my friends said, well, I'm not gonna buy an electric vehicle until they have lots of models available between 30 and 50 grand with a range of at least 200 miles. So I just checked the price, and this is just a chart I put together today. And you can see that there are many models available that are under 50 grand and have reasonable range. The more money you pay, the bigger the battery you get and the bigger the range you get. So it's all a question of getting what you pay for. But this option means that many people can now look at an electric vehicle. And so some of the policy stuff that's happening that's really impact on electric vehicles is that many countries are now talking about banning in ICE, you'll see that a lot. It's an internal combustion engine, so a traditional gas car. I just noticed today the UK had said they were going to do it in 2040. Now they're saying they'll bring it back to 2035 to meet their climate change targets. It's part of meeting their climate change targets. So this means that auto companies have decided to invest very heavily in the electric vehicle market, all of them, and some of them have actually said we'll stop making gas engines after another few years. And so what does that mean for how many cars are on the road now and how many cars will be on the road? And for the older cars, we're now beginning to see the batteries coming back, and that's what I'll be talking about. So if you look at this table, it shows the number of hybrids, plug-in hybrids, pure electric vehicles that were sold in the US or since 2005. And you can see we never were able to get good numbers for 2018 or 2019 for that matter, but you can see that the numbers are steadily going up. Once the plug-in and pure electric were introduced to the market, they began to take over a bit of the market popularity. But certainly every year now, at least 500,000 or more, some kind of electric vehicle are sold in the US. And so where do we think this is going to go? Well, whichever report you read, they have all different forecasts, and you can see many forecasts between now and 2025. The different people do these forecasts, you know, investors, some of these like Navigant are a consultant, and Barclays is a bank. They all want to know, where's this market going to go? And so when you look longer term, you can see that in 2018, 2 million electric vehicles were sold, which was 2% of sales. And people are doing projections now up to about 2040. And this particular projection says that 54% of cars sold by 2040 will be electric vehicles. I think it could be more. It just depends on how some stuff shakes out. And so I'm just focusing on cars, but we have lots of other vehicles that run on batteries or can be run on batteries now. Buses, garbage trucks, underground mining vehicles, delivery trucks, scooters, and everything else you can think of. So now I want to talk about what happens to the batteries in the vehicles when they're done. So just to explain what happens to the batteries, I just need to explain the difference between the different kind of electric vehicles. So you've got a hybrid, which is really a gas vehicle with a small battery, or you've got a plug-in hybrid, which has a bigger battery, but it still is a gas engine. And then you have a pure electric vehicle that has a really big battery and no gas engine. And so each of these types of vehicle has a different battery. So for the hybrid, the battery's quite light. 30 to 60 kilos, and most of those batteries are nickel metal hydride batteries. Some of them use lithium batteries, but mostly nickel batteries. when you move to both the plug-in hybrid and full electric vehicles, you have to have a lithium battery because you need the energy density. So those two sets of cars are all run on some kind of a lithium battery because of the lightweight and the energy density. And so how many of these are going to be coming out in the next number of years? So we ran the number for a client, and for the US, you can see that it was mostly nickel metal hydride batteries that were showing up at wreckers yards in cars or just at dealerships, because the number of cars that had been sold 8 or 10 years earlier were, you know, the battery was done. So the numbers, but if you look at 2030, it'll be about 1.2 million electric vehicle batteries will be at the end of their life. So that's getting to be a pretty big number when you think of how heavy they are. So this is what an electric vehicle battery looks like. It's the battery's big, it's underneath the body of the car. It's made up of a bunch of boxes, which are called packs, and inside all these packs are lots of cells, little battery cells. So to do planning, we normally say that electric vehicle batteries last about 8 years or 100,000 miles, but some of them last way, way longer. And in fact, Toyota, when they brought out the Prius, they gave a 100,000 mile warranty on the battery, but they didn't really have any idea how long the battery would last. That was just a wild guess. But some of them last 200,000 or 300,000 miles or 150,000 miles, I often hear. So they might last 8, 9, 10 years, but eventually they're no good for the vehicle because they've lost their charge. So the difference between them and the batteries we're used to in vehicles is that a lead acid battery that you need for starting and lighting an ignition in your traditional car, when they're dead, they're done. You have to recycle them. But when electric vehicle batteries are done as a car battery, they still have most of their charge left, about 80% of their charge. So they're really still suitable for reuse in energy storage, backup power, and a number of other applications, which I'll talk about in a minute. And there's a huge amount of research underway right now on all the applications that these batteries can be put into after they're no good in the car. So this chart shows the second life options for electric vehicle batteries. So on the left-hand side, you see the HEV, which is the hybrid. The EV and the PHEV stands for the electric vehicle, and the plug-in hybrid. So when the batteries are done in these cars, this chart shows them going into a storage battery system. So that could be for renewable energy. You combine the battery with a solar panel, all of a sudden you've got a 24-hour energy supply, or with a wind turbine. Or it can go into an office building as backup power, or it can go into the grid, the electricity grid, as energy storage, which stabilizes the grid. And once they've done their time in this second application, which leads to a stable power supply, once that battery's done in that second life, it goes to recycling, the materials are recovered, and they go back in to make new batteries. So that's a nice little chart showing a nice circular economy concept for the battery. So I'll run through a few examples. So for instance, in Japan, not in North America, Nissan take batteries out of the Leaf car. They do a state of health testing, see how many of the cells are alive or dead or in good shape. They recombine them into new cell packs, and by replacing the dead or low power cells, and then they resell the whole thing as a reconditioned battery. And so this is actually a very clever thing for them to do, because maybe the Leaf has 2 or 3 years left. People don't want to buy a new battery, but they'll buy a reconditioned one. And so a new battery would be $6,000, and the reconditioned battery is about $3,000. So Nissan do that as a business, quite a clever business strategy. In North America, we've got some really, in the US, you've got some really good examples of companies that really are leading edge on how to reuse batteries. One of them is in Oklahoma City. It's called Spears New Technologies, SNT. They deal a lot with dealers' warranty replacements, also batteries from test projects. For the warranty replacements, if something went wrong with the battery, they do a root cause analysis. and then they report back to the battery company and the car company what was wrong with the battery. They repair it, and then they decide, should it go to remanufacturing, refurbishing, or repurposing? These are all different terms they use for different streams that they send the repaired battery into. So they classify and grade each battery that they repair, and then they decide it can go back into a vehicle, maybe labeled as a reconditioned unit, or else into what they call the second use market, which is mostly energy storage. And then for packs that have significant wear and tear, they just tear down the packs and send the small components for recycling. So that's a very good leading edge company that's profiled quite a lot in this business. There's another company called Big Battery in Chatsworth. They're in Chatsworth in California. They're also in China. And one other country, I think is Germany, somewhere in Europe. It was founded by Eric Lundgren. He's a really great social entrepreneur. He founded another company a few years ago, IT Asset Partners, but he got on the wrong side of Microsoft, so he had to do some jail time. But anyway, he's out of jail now, so he's running this great company, and it is the largest supplier of reconditioned batteries in the US. It's sort of the same idea as Spears. They test and grade all the used batteries they can get their hands on. They combine them into lower energy applications, sometimes like drones and wheelchairs. And I just checked their website today, and they've got such a huge range of products, something from like $5 to $40,000, depending on what you're buying. But they have batteries, battery management systems, connectors, backup power, all kinds of stuff that they make, all with batteries that come out of electric vehicles, or old industrial batteries are probably in there, as well as consumer batteries. So two good examples of what happens to batteries when they're done. And so how long, one of the big questions is, well, how long do these batteries last in this second life? Because, you know, after that, they should go to recycling, and the recyclers want to know, when are we going to see them? So for energy storage systems, we think those batteries could last another 10 years. If they go into power support to fast charge EV electric vehicle stations, they might last 30 years. Home energy storage, 12 years. And, excuse me, grid-oriented service, 6 to 12 years. These are all modeled numbers. We haven't had the years of experience to actually measure it, so they might last less time or more time. That'll become clear over time. And so this chart shows all the applications for different kinds of batteries for energy storage, electric vehicle charging, base stations, low-speed vehicles. And the black line shows how much of that demand we think could be met by old batteries used batteries from electric vehicles. So a big market. I'll just talk briefly about energy storage, because it is actually very important for many things. And so energy storage basically means you store energy from various electricity systems for different reasons. So you can store energy because you want to have it for system peak shaving, for load management, for backup power, for frequency regulation, all kinds of stuff that is good to have on an electric grid. But in the past, it wasn't always there because it was expensive. But now with the price of batteries coming down, it's getting to be much, much more popular. So many states have policies on energy storage where they really want to see more energy storage for more stability of electricity supply. So some states set up procurement mandates and incentives and require you to have energy storage as part of your long-term plan. So for instance, California in 2013 set a mandate that investor-owned utilities had to have 1,325 megawatts of energy storage across the transmission, distribution, and customer levels by 2020. Some states are subsidizing storage or mandating its adoption, or else they've set targets, including Maryland, New Jersey, Nevada, Oregon, Washington, Oregon, New York, and Massachusetts. And so all of this stuff's happening as the electric vehicle batteries are beginning to come out of service. So there's a very natural place for them in this energy storage space. And so as the lithium battery design is getting better, batteries are getting cheaper, and the supply is starting to grow, and there's a natural place for these batteries in energy storage systems. So this chart is from it's actually from Bloomberg. It shows that the red line is all these batteries that are coming out of vehicles, and the blue line is what Bloomberg thinks will happen to these batteries in terms of being converted into home energy storage. That's only one application for them. And so here are a few examples of batteries from electric vehicles that have been used. This is a GM facility in Michigan where they took used Chevrolet Volt batteries for energy storage at their facility. This is BMW in Leipzig in Germany took a whole bunch of car batteries for another energy storage plant. In Sweden, Volvo took the batteries from electric buses to store solar energy in apartment buildings. This is just a picture of a great stadium in Amsterdam, and it has lots of electric vehicles, 63 used electric vehicle batteries and some new batteries just to put the system together. And if you looked under the hood, this is what the system looks like. The lettering is small, you may not be able to read it here, but they've got all kinds of neat energy features in this building, mostly as demonstration, but they used to get huge crowds before COVID, so that was a great way to educate people on the topic. I'll now move on to the recycling of electric vehicle batteries. So just to start, electric vehicle batteries are different to the batteries we're used to. So all of our cars have a lead acid battery for starting, lighting, and ignition. And we know they die out after about 4 years. When that happens, they are incredibly recyclable because the lead is worth so much money that 99% of the lead acid batteries in the US get recycled. And we believe that within 6 weeks of you changing your battery by whatever means, the lead and the plastic in that battery has been made into a new battery and is back out on the street. So everything in that battery gets recycled. That's a very well-established supply chains. But when you come to electric vehicle batteries, they're heavier. So you can lift out a lead acid battery yourself, but you absolutely cannot lift out an electric vehicle battery. They're way too heavy. They have different materials like lithium and cobalt. They're much more complex to recycle. And in fact, they're quite dangerous to handle. People can get electrocuted handling them because they've got a lot of charge. And so the recycling, because there's not enough of them yet, the recycling infrastructure is just not developed really. I'm just reminding you of what these things look like. They're big and they're heavy. This is a Tesla S battery pack. It has over 7,000 cells. They're Panasonic 18650 cells, kind of a standard battery cell. This is a Chevrolet Bolt battery, and what you can see all the boxes containing all the cells to make the battery work, but all this orange stuff is wiring that has to go all over the place, motherboards, a lot of electronics to get the whole system to work. And so to recycle this battery, it takes a lot of dismantling to take it apart and send stuff in different directions. So the components of an electric battery, I need to explain this because I'll be talking about cathodes a bit in a few minutes. You have an anode, which is made out of natural or artificial graphite, which is carbon, although they may replace that with silicon in the future. Then you have a cathode, which is a combination of nickel, cobalt, lithium, manganese, aluminum, and any other materials depending on the chemistry that the company's using. So Tesla uses one chemistry, GM another, Volvo another. They all use slightly different chemistries for different reasons. And And one point worth mentioning is that cobalt is one of the elements in most of the batteries, all of the batteries right now, and it's very, very expensive. So they're all trying to get rid of the cobalt, but not too successfully so far. And then you have the electrolyte, and that's where the lithium is. And you've got a separator, which is some kind of plastic, but mainly the metals are really what you're looking for out of the battery. And so different chemistries used by different vehicles have different combinations of these materials. There's 13 common chemistries. This is one of the problems for recyclers, that if you're looking at a lead battery, they're all the same. Electric vehicle batteries are all different. And so the purpose of the recycling is to recover the valuable metals, which we call the energy metals, sell them into metals markets, and then they're sold back to the battery guys. And that's the way the system works. So each electric vehicle battery contains up to $3,000 worth of metal, but the challenge is getting that metal out of the battery, which is not easy. And so traditionally, for lithium ion battery, we call it lithium ion or lithium batteries, to recycle them, you take the battery out of the car. That's a big deal, because for a Tesla, it actually weighs 1,000 pounds. So you have to get it out of the car first, then you have to dismantle it, which means taking all the wiring out, opening the big metal structure and getting all the boxes of little battery cells out, disconnect the battery management system, as I said, motherboards and wiring, a bit of a job. Then any steel parts can go into steel markets. And if you have plastic parts, they can go into plastic markets. But the main money-making effort is to process the cells to recover materials suitable for smelting. There's very few companies that do this globally, and really few that do it in North America, but there is one in Canada. So all the US, it's owned by a US company called Retrieve. So they send all the big batteries up to Western Canada. So Retrieve and Trail BC, which is way in northern BC in the middle of the mountains, they process all the batteries to get a filter cake or a matte with cobalt and nickel. They send that on to Glencore, which is in Sudbury, Ontario, the only North American smelter that does this to get the nickel and cobalt out. And then they recover the lithium to send to a paint industry. Other smelters globally who do some of this, there's Umicore in Belgium, there's probably one in South Korea, and Retrieve in Ohio does nickel batteries. So there's not very many people in this business. Companies involved in the lithium ion business, the recycling business, I've mentioned most of them. There's a South Korean connection with Sunjeel, a few other companies, one in Michigan, one in Worcester, Massachusetts. I've mentioned Retrieve that are in both the US and Canada, and Glencore that's in Ontario, but they may be sending everything to their smelter in Norway. And then a big company called Umicore in Belgium operates globally, but they're big smelters in Belgium. And the processes we have today are maybe 60% efficient. So they get 60% of the materials they're trying to get out. And the way it works right now is the smelters will pay you for the nickel and cobalt. Then the recycler who sends stuff to the smelter, they might charge the customers for the recycling service, and they might give them a break on the price depending on how much money they got back for the nickel and cobalt. But all these companies are used to recycling consumer size electronics and some industrial batteries, but they're not yet used to the electric vehicle batteries. And so there's a new kid on the block, or a new idea, which is not fully operational yet, called direct recycling or cathode to cathode recycling. And so the idea is that instead of partially processing batteries and sending them off to the smelters to where they make all the money, why don't you keep the batteries and try and leach out all the valuable metals and then sell them back to the battery companies, and then you'd make much more money. And so the idea is to have higher material recovery, like 95% instead of 60%, make more money, and it uses less energy. It's more energy efficient. So numerous companies are trying to develop this technology now. There are a lot of technologies around, a lot at the early commercialization or research and development stage, but none of them except maybe one is yet at full scale. And each company has what I call the secret sauce. They've got their own processes that they will not share any information with anyone. But numerous players are in this space right now, like universities, private sector combined with universities, battery companies supporting university research. So I'll just flash up a few names. There's a company called Li-Cycle in Ontario, where I live. Government has given them a lot of support, but they're actually building their first facility in Rochester, New York. It might just be open. I don't know quite what the status is. There's another company called American Manganese in British Columbia. They have a manganese mine in the US, and they took some of the technologies from that mine to try and develop a direct cathode to cathode technology. Another company called Lithium gets a lot of support from the Canadian government, and there are numerous others, mostly at laboratories and universities. But one concern that has been raised is by the time the battery comes back, which is 8 or 10 years after it went into the market, new chemistries are being used, and maybe the materials you get back from the old chemistry can't be redeployed into new batteries. So they haven't fully worked that part out, but it's a to be continued kind of story. So when you look at electric vehicle battery recycling in the US, there's no collection infrastructure yet because there are only onesies and twosies at scrap yards and dealerships, and it's expensive to move them to a central location. I think I've mentioned Umicore in Belgium. They do have a consolidation facility in either North Carolina or South Carolina. And they've said when there's enough batteries in North America, we'll build something in North America. I did mention Retrieve already. They've got sites, a number of facilities in the US, but they ship the lithium batteries up to Canada to be processed. And Tesla's Gigafactory in Nevada is, we don't have too much detail, but they're going to be making batteries, and they've said they're going to have recycling and refurbishment facilities on site. And there's a company called Redwood Metals that the co-founder of Tesla left Tesla, J.B. Straubel, and he's starting a recycling facility, a company of his own. So Rick Perry, launched the lithium-ion battery recycling prize beginning of last year. $20 million investment in lithium-ion battery recycling technology. They want to see these new technologies developed, but it's only a drop in the ocean compared to what other countries are paying. Like Europe is investing 100 billion euros, which it is 100 billion because numerous car companies are pitching in. I forget what they call the fund, but it's just they are throwing money at it like drunken sailors, like there's no tomorrow, because whoever gets there first in terms of figuring this out has a massive, massive business to cash in on. So when you look at all this, how many electric vehicles are coming? We'll reuse the batteries for a while, but then they'll eventually need to be recycled. The key things to think about when it comes to batteries for electric vehicles is that the price is continuing to fall. And as the price falls, the demand will go up. And the key concern people now have is the supply risk of the materials needed for the batteries. So to make these batteries, you need lithium, cobalt, manganese, and nickel. There's lots of lithium around. We have lots of lithium in Canada. You find lithium in stable. Australia has plenty of lithium. Chile, Bolivia, Argentina, lots of countries that you can do business with. The cobalt is a problem though. It's needed for the batteries, and 60% of the world's supply is in the Democratic Republic of Congo, which is a crazy country, politically very unstable. They have many artisanal miners, child labor, You know, so there's an issue around ethical sourcing of cobalt. And they send all of their cobalt to China to be processed, and then China uses it to make batteries. And nickel, Elon Musk has signed big nickel contracts with people to supply him with nickel because he was worried about a nickel shortage. So the supply risk of having enough materials from stable countries to make the batteries is probably the biggest issue for all of these companies. They need to have a stable purchase cost of the expensive materials to keep, again, the price of the battery under control, so that as the price keeps dropping, the demand will increase for more vehicles and more batteries. In some cases, there's legislation mandating recycling, which is why people are interested in recycling. If you put a vehicle onto the market in the EU, the European Union, you have to, as a producer, pay the cost of recycling either through the end-of-life vehicle or through the battery directive. Either way, you're covered by one type of legislation or another. California has a committee looking at this right now. I think they're going to be working on it until 2022. And British Columbia and Canada is probably going to regulate mandatory recycling. There's also a bit of a reputational risk for big car companies. They don't want to see their batteries being dumped on the side of the road, so they want to make sure they're recycled. So these are the drivers for the battery recycling market. It is partly about money and business, mostly about money and business, I suppose, at the end of the day. But that market will get developed for sure. There may be a cost. I mean, if you look at a £1,000 Tesla battery, right now they're charging 4 cents a pound to recycle, 1 to 4 cents a pound. So it's, you know, $1,000 to $4,000 to get that recycled, unless the new technologies kick in earlier. So that was the whistle stop tour. There might have been a few questions on the chat.
Thank you, Maria. Can everybody hear me?
Yes.
And Maria, if you can unshare.
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 Okay.
Perfect. Okay, you guys, we've had a couple of questions, but Maria's answered most of them. I'm going to hybridize a couple of them, or one of them, and while you get some stuff in, I want to ask one. How much does your dealer charge if you want to keep your Prius battery when you have to have yours replaced? Or do they charge? Can you just keep it?
Oh, I don't know the answer to that. That would be an interesting one. So someone wants to keep, yeah, I don't know the answer to that, actually. That would be an interesting one if you wanted to keep it. Yeah.
If you want to buy one for home energy storage, are they cheaper than buying a battery wall?
Oh, you would just have to do I mean, if you wanted to buy something for home energy storage, I'd say go on the Big Battery website. They had some very interesting home energy storage stuff. And Spears have I forget what they call it. They have a home energy unit as well. So you wouldn't buy an electric vehicle battery for home energy storage. Actually, you'd buy a home energy storage battery, which would be cheaper per kilowatt.
Okay, let me get to, let's see, Bob had one I can ask part of. He asked how important fast energy charging was for longer trips. What is the future of fast charging stations? How fast are we going to get fast charging stations?
I think they're down to 20 minutes, I think now. Maybe they'll be down to 10. They are important to the future of, you know, needing to charge up and get going. But in the time it takes you to go in and grab a coffee, you can probably charge up even today, I think. But yeah.
Let's see. From Chris Batel, Chris, excuse me. Should we jump into an EV now or wait 2 to 4 years?
If you're really ready to buy a car, definitely buy an EV. But if you can wait, the cost will go down. So I drive a hybrid now, but my next car will be full electric, and I'm going to see if I can wait 2, 3, 4 years, because the technology will be better, the battery technology will be better, and the price will be lower for sure.
So we're going to get all of the above. One of my big questions is the battery technologies and the replacement of some of the challenging metals. 2 to 4 years, somewhere in the not too distant future, are we going to have better technology, as better chemistry, as well as more efficient technology?
Well, I think what they're trying to do, they're always looking for better technology. So the longer you wait, the technology gets better for sure. What most of the battery people are trying to do is get a cheaper battery, and cobalt is the expensive part of the battery. And they've gotten it down to, Panasonic works with Tesla. So they've got it down from, I don't know, maybe it was 15 or 20% cobalt a few years ago. Now it's down to 3% cobalt. They're trying to get it to 0. But cobalt stabilizes, battery chemistry is very unstable, and the cobalt provides the stability. So, numerous companies are trying to have cobalt-free batteries. The recyclers are not happy when yeah. The recyclers are not happy because they say, if you take the cobalt out of the battery, we don't want to recycle it because there's nothing in it that we're interested in anymore. We can't make money. So that's not going to influence the decision of the automakers or the battery makers. So they'll just get better. They'll get lighter, more energy density as time goes by. Massive amounts of research is being put into this issue right now by everybody, I would say, yeah.
Al Braden is asking if you've got any insight onto when leaf recycling will come to the U.S.
Leaf, you mean Nissan Leaf recycling?
Right.
Of the battery?
Yes.
Well, if you had a Nissan Leaf battery now, you should definitely ring Nissan and say, what do you do with your battery? They probably send it to Spears in Oklahoma, actually. A lot of the manufacturers do that. When we do research, it's very hard to get a straight answer out of any of the dealerships on what they do with the batteries, but they do have systems for, certainly GM, any of the big names definitely send the batteries somewhere to be recycled. So,
who's Spears in Oklahoma?
they are a company that a lot of the OEMs, which is the original equipment manufacturers, a lot of the auto people send the batteries back to Spears. And the reason they like sending them there is Spears kind of does a diagnostics on the battery, which helps improve the design. And then they test it, every cell, and then they recombine the good cells into a new reconditioned battery that they sell, for revenue. So.
Gotcha. What's the fire risk with the batteries?
Well, lithium batteries there is always a risk with lithium batteries, but I would say when you buy a new lithium battery in a car, very, very few cars have gone on fire because of the battery. But what happens with the lithium battery sometimes is if you've got one cell that's a bit weak, the other cells work harder and they overheat. And if you reach a certain temperature, then it causes a fire, which is very hard to get under control. But there's virtually I have not heard of cars going on fire hardly ever with a lithium battery. But lithium batteries are very flammable.
It was just that one brand of phone.
Oh, well, I mean, I have loads of stories from recyclers of batteries that have gone on fire, at their yards, or, they bend something to try and get the lithium battery out, and then the thing goes crazy. So
Short them out, yeah. And thanks to Deanna Dossie for that question. Let's see. Steve Poole, why are fuel cells not more popular? Any ideas?
They will be. I mean, I think what we'll see, so in the next few years, we have, I think electric vehicles are pretty mature now. Like it's a mature enough product that the market will develop, but you'll begin to see hydrogen and fuel cells develop more in the next few years. So probably cost is usually with fuel cells, that has always been, it's always been a bit more complicated than just a simple battery. But I think that everyone's looking at both hydrogen and fuel cells as new fuel and energy sources. So look 5 years out, I think there will be more happening there.
And Mr. Fusion, maybe. Al Braden asks, oh no, Al Braden just mentions that using car batteries at home requires a lot of electrical interface. I'm looking forward to figuring that out.
I would certainly have an electrician do. I would have someone who knows what they're doing do this, unless you're very, yeah. If you're going to do it yourself, if you kind of know how electricity and batteries work, then
engineer.
Okay.
Julian asks, what are the whoops, I missed that one. I'll get back to you, Julian. Anita asks, why do the cells wear unevenly?
There's probably a fractional difference in the quality of the cells, which means that one gets loaded up more than the other. Or where they're placed in the pack, maybe the charge, you know, gets unevenly distributed in the pack. So.
Yeah, gotcha. Back to Julian, what are the risks of environmental contamination, harmful byproducts in the recycling process?
Well, the recyclers, any of the ones I talked about are big companies with environmental permits that are very strict about what they discharge in the air or the water. So I would say they are a well-controlled industry because they're big. So I would say very little. You wouldn't have that many contaminants out of a lithium-ion battery anyway. You know, you've kind of got lithium, cobalt, manganese, nickel, you know, you've got only a certain number of things in it. Bit different to lead. If someone wasn't managing lead properly, that would be more of an issue, but the materials in a lithium battery would not be big polluters really, but they're very well controlled because all these companies are, you know, big facilities that have permits.
Barry Lynn Hill makes a nice editorial comment, which leads me to a question about the 500-mile Rivian that's supposed to be coming up next year.
Oh, yeah.
Is that going to be a thing?
Yeah, it will be.
Is it just a truck or an SUV chassis that can hold a giant battery? Is that all they're doing, or they got some secret sauce?
No, it'll just be one of the numerous battery chemistries. I'm just actually trying to speed read the questions while we're chatting. It'll be one of the Rivian always are coming up with neat stuff. It'll be just a pretty big battery. You know, if you looked at, if you looked at the table I had earlier, the more you pay for the car, which is mostly battery, the longer range you get. And so, you know, a bigger battery will get bigger, longer range. So basically, I think the battery will be bigger. They'll have made it slightly denser in terms of energy density. But
so
yeah,
it's coming. That's really
so.
Cool. Dale Bola makes a cool editorial. What about the thousands of internal combustion engine cars that catch on fire?
Right, yeah. No, the battery one is a better story. No one's interested in a car going on fire unless it's got a battery. Then they're all over it.
Our buddy Tom Smitty Smith asked if, says this is a great presentation. Could you share your slides?
Sure. I think Phoebe, what were you going to do with them? Is she there? Yeah.
I believe this is being recorded and it will be placed on a local Sierra Club YouTube channel. Is that right, Bob?
That's correct. And we are recording.
And I'll email the slides to Bob and Phoebe. So I just made a few last minute changes. So
and Smitty is a big EV guy, and he would love your slides.
All right.
So with permission to use them, or at least to study them deeply and sleep with them, I imagine.
Okay.
So let's see, Carolyn, what is in the electrolyte? And is it also recycled or recyclable?
Yeah, the electrolyte is the lithium salts, and yes, it's recycled to a lower, what we could say is a lower grade application. So some of it goes into the paint industry. It doesn't go back into batteries because the lithium's not high value compared to the other materials in the battery.
Is there a future for solid electrolytes? And I'm not, I know that these batteries, it's not a liquid, but it's not a solid either, right?
No, and so the solid batteries that are coming will be less flammable. So that's what they like, the solid electrolyte, because it's more stable, it's less flammable.
And our buddy Al Braden also mentioned Professor Goodenough at UT. Do you know Professor Goodenough's work?
No, I don't. Well, I might. I read a lot of stuff, and I don't always know who produced it. But
put that on your list. I can't remember exactly what he done, but he was responsible for one of the big breakthroughs in the past, and has published in the last 2 years, I believe, on the next big breakthrough. I can't remember if it's battery chemistry or what it was, but
batteries are the future, because the future is electric, to get away from carbon, and so to be electric, you have to have batteries. So,
all right.
Yeah.
If anybody else has some more questions, I hope I didn't miss anybody's. We're down to the last. I think I had.
I was just thinking that it's about.
There was one from Barry Lynn Hill. She actually had a question in there.
Do you remember what it was?
She was trying to figure out when is best to buy a new car and which one. She has a Leaf now.
All right.
Oh yeah, which one? We've got the 2 to 4 years.
Oh, it's good to know.
She wants
I don't know when I figure it out, I'll let you know. Tesla would be Tesla will have cheap versions, so it'd be nice to have a cheap Tesla would be good. So yeah.
And the folks here on the list said that Goodenough was I think he invented the lithium-ion battery, not just a leader. And he's in his 90s. He's a Nobel laureate.
Oh, right.
That guy.
Now that I see the name, yeah.
Goodenough.
What an interesting name. Yeah.
So that's. Let's see if anybody got a last-minute question in. This has been wonderful, Maria. We really appreciate you zooming in from Canada. This has been awesome.
Yeah, it's such a treat to have speakers from outside of Austin while we're doing these Zoom things. It's kind of neat to get some long-range speakers in.
Well, I like to spread the word on electric vehicles, because every time someone says something about electric vehicles, it's part of a future story that's coming.